All right. So hello, everybody, and welcome to our GLSec at Home talk. My name is Corey Crocht, and I will be the host for tonight's talk. As we all know, the pandemic has not only changed how we work, but it's also made us rethink how we network and learn. We do hope to get everyone together again soon in person for the next Great Lakes Software Excellence Conference. But until then, with the support of Software GR, GLSec will be hosting one of these events each month. We're calling this GLSec at Home. But first of all, we could not do any of this without the support of our sponsors. And because we want all of you to know about the organizations that support West Michigan's software development community through Software GR, each talk will be hosted by one of our wonderful sponsors. Hosting allows our sponsors to talk directly with our community, showcase their organization, and share what they bring to West Michigan and beyond. Make sure to check out all of our sponsors in detail after the talk. If you want to become a sponsor, please let us know. So our sponsor for today is Paul from Grand Valley State University. And so I'm just going to hand it over to Paul and let him take it away.
Thank you, Corey. And I just want to acknowledge that I am very proud to see the success of GLSec at Home. Grand Valley State School of Computing has been a supporter and sponsor of the Software Excellence Conference, GLSec, and Software GR since its inception. And so in these pandemic times, it's kind of neat to see us be able to come together with the at-home variety. And so that's exciting. For those of you not familiar with Grand Valley State School of Computing, we offer 8 bachelor's or master's programs in computer science, information systems, information technology, cybersecurity, data science analytics, health informatics, bioinformatics, etc. And while we currently have over 1,000 students, either undergrad or graduate, in those programs, we recognize that that's nowhere close to meeting the demand for those skills that many of your companies are looking for. And so in addition to a traditional 4-year bachelor's or graduate degree, that there are other paths that the School of Computing provides and wants to be there for you. So stuff like boot camps, short-term digital badges in specific technology areas, certificates. There are ways that the School of Computing can help you continue and advance your technology career, or if you're what we call a career switcher and you wanted to move from the business ERP side, let's say user support, into one of the advanced analytics or a cyber field or something, we would like to be able to be there for you. But tonight, we're just happy to sponsor and help continue the GLSec at Home. And so, Steve, I look forward to hearing your talk, and good luck to everybody.
All right. Thank you, Paul. And thank you to Grand Valley for supporting Software GR and GLSec. So now I am pleased to introduce Steve Miller as our speaker for tonight. I have had the privilege to work directly with Steve over the years. And he is, in fact, one of the most talented people that I have ever had the privilege of working with. So I'm really excited that he was willing and able to join us here tonight, and I'm really looking forward to his talk. Steve is a DevOps practitioner who enjoys creating robust architecture, leveraging development and operational best practices. His 18+ years of experience cover a wide variety of platforms in the public and private sectors. His background also covers various virtualization, storage, and backup technologies. So with that, Steve, it's all yours.
All right, thank you, Corey. Let me share my screen real quick. Panelist. There we go. All right, everyone. Thank you again, Corey, for that introduction. Appreciate that you had good, fond memories of our time together at Gordon Food Service when we worked there. As Corey mentioned, I call myself a DevOps practitioner. My technical title is a senior systems engineer at Plex Systems. And just to add clarity, that's not the Plex that a lot of you might be familiar with from an AI standpoint, but it's the Plex. It's actually a manufacturing ERP system. And it's funny, Paul mentioned about, upskilling yourself to different, to transition, because a lot of my talk is going to be taking traditional development methodologies and taking them into what is normally a traditional operational role. So just to kind of frame it, so this would be what like a traditional sysadmin, network engineer, those type of titles. And in the past, that has never really been, as a sysadmin, you never really worried about development methodologies, right? You racked and stacked servers, you set up backup systems, you set up authentication, a lot of those other other goals. But in a modern era, I think that a lot of the newer development technologies can certainly provide a lot of benefit, and certainly is worth taking a look at to help improve your own practice, as well as, develop your own career path. Kind of taking, I want to say, a more agile look. I don't want to necessarily overuse that term, but, in today's environment, if you think of technology in the past, racking and stacking, you'd bring in a big project, a software package, and you would actually purchase hardware ahead of time, right? And you would, get space within your own private data center. You'd work with your network team, your storage team, purchase the hardware, bring it in, rack it, and then you would depreciate that asset over 5 or 7 years, right? Very slow moving, very, methodical way of approaching information technology. I think in the modern era, any, last decade and a half, cloud technology, not to you, has certainly changed that perspective, right? That now, if I want a server on the internet, I can do it with a credit card and, a few minutes at Amazon or Azure or Google Compute. So I think the expectation from the business is that type of on-demand solutions. So I think internally, operational teams have to kind of think of themselves as providing services and competing in some ways with a lot of this, a lot of cloud services. I think everyone is, that's working within technology has had issues with a term called shadow IT, right? That some business department takes their, private purchasing ability, purchase a SaaS solution, right? Doesn't really run it by anybody in IT until it's already, been gotten its foothold within the company. And then all of a sudden there's either a security breach, or all of a sudden the help desk begins getting requests for support, right? So, and then you're left kind of behind the 8 ball per se. So a lot of this is trying to get those operational teams kind of thinking of the business as a customer and providing those resources at a faster pace. So the first thing I'd like to talk about real quick is that we have to also think about selling change. So I'm going back. So let's say there's a traditional operations group, right? Sysadmins, either on a Windows or Linux side, and you're trying to explain to them, or trying to sell this. Either you're an individual contributor on the team and you want to sell this idea, or you're a manager and you're hoping to get your employees on board, and hopefully with a more enthusiastic approach than just, ordering it from on high. So change is always hard, right? And it's always good to think about how are you going to sell this? And there's certainly a lot of benefits. The biggest thing from an automation standpoint is reducing toil, right? Operations teams tend to have a lot of activities, if they're not optimized, that are tedious, right? That are very repeatable. So it's really good to take a look at reducing a term called toil, which is a term Google kind of coined, I shouldn't say coined, but expressed in their SRE book, which is a really good read. There are links within the notes of this presentation. So I would encourage everyone, if you haven't, to read Google's Site Reliability Engineering book. It's freely available if you wish, or you can pay if you want a hard copy. It's certainly a Google perspective on such change, but it's got a lot of good reading material, really good emphasis on how to structure operations teams to make them more agile, make them fit within a faster pace of technology. The other benefits, so a lot of this goes to benefits of version control. So take an approach of getting a lot of your practices automated within a scripting language of some sort, or some sort of configuration management system. And version control brings about a lot of benefits that I don't think developers, they're so used to having version control at their disposal, you don't even think about the benefits. But a true history of change, right? That if something breaks and I want to know who last changed this script, and more importantly, why did they change it? Version control generally provides that. Maybe not the whole thing, right? You can make bad commits to your code, but it at least gives you kind of, bluntly, a blame report, which is what it's literally called. Like, who changed this code last? So at least you have someone to talk to. In a traditional sysadmin approach, you generally don't have, you have a setting that was changed, or you have a script that who knows, well, it was changed 3 months ago. I don't know who changed it. I can guess. But providing just that background actually has been really beneficial in the places where I've seen this implemented. Documentation generally, not that code is always documentation or should be seen as a replacement, but if it's at least a script that is run, that's at least a process that exists, that an artifact that can be analyzed. A lot of departments, good departments, keep documentation separate, and it's a really good process. But the hard part is you tend to get the documentation tends to become out of date fairly soon, right? Changes are made and then someone forgets to update the documentation. That's a completely separate concern. So a lot of times documentation isn't quite in sync with the operational system. If you have a process where your code actually is in charge of everything, of deploying, then that makes it a little harder for that to become out of sync. Peer review is also a good thing. Again, another item that a lot of development shops, you don't think about, right? That well, of course, all my code is reviewed by a coworker. There's comments made, there's changes, to improve the code base itself and to also spread that knowledge. But bringing that kind of thoughts into an operational realm, really beneficial. Now, of course, there are concerns that you should address. A lot of operations people don't want to think of themselves as programmers. They're like, well, I started in IT. I didn't really like programming when I was in college. So you know what? I decided to become a sysadmin. The one thing to emphasize is that you don't have to necessarily have the full background of a developer to do this properly, right? Well, it helps, but just automating something in a script is a starting point, right? So emphasizing you don't need to be a full-on programmer. You don't need to know data structures and sorting algorithms and all the other kind of hardcore CS concepts that would be expected of a programmer. Now it might develop into that as the skill set of the team grows, but it isn't a requirement to get started to view the benefits. The other item of concern is in an outage situation, it may slow me down. And this becomes more of a concern if you have infrastructure as code. So you've defined your entire cloud infrastructure or even on-prem infrastructure within a code base of some sort. And the thoughts are, well, if that's defined as code and all of a sudden a bug happens and I need to quickly make changes, this code's going to slow me down. That is a legitimate concern, of course. I've seen it approached a few different ways. Either you allow the change to happen and then you have a good remediation process to eventually backport that into code, or you have a very streamlined system for pushing out changes in an emergency, which really is the ideal way to do it. Again, requires a bit of planning, but at the end, I think you can address those concerns. But it's good to at least bring them up, right? Because when you talk to your team, there might be legitimate concerns, and you definitely want to be ahead of that. I would encourage working within your environment. If you're in a company, generally you have development groups that are already doing version control, already doing code pipelines. So, decide to reach over and talk to the development groups. Now, I specifically didn't label this presentation as a DevOps presentation. That is a far harder discussion or bigger discussion, right? As far as embedding operations within development teams and how you approach that. I didn't want to necessarily do that. That would be a longer discussion, but this this presentation could be seen as like a stepping stone to such a bigger change, but not necessarily a requirement. But it's good to leverage that type of background. If your organization already has expertise in particular version control systems, in particular processes, leveraging that, is super beneficial, and could lead into more collaboration between the operation development groups. If I'm using the same code base, maybe not necessarily the same code base, but at least the same code tools. So a development team could actually look at these scripts that operations is using, could offer input, could offer advice. And conversely, operations teams could actually look at some of the deployment pipelines within, say, development and offer advice based on their background and expertise. So you're beginning to see kind of the intermingling between these two, what were traditionally separate departments. But again, you might not want to necessarily mention that right away. Again, selling something like this is a difficult conversation. Depends really on your organization, on your team, and making the case. One thing I do want to emphasize, though, is if the tools that your development team is using don't fit within what you want to do in your operations team, don't be afraid to go it alone, and use a tool that's more appropriate. But I would certainly offer caution to such advice. And also, one last piece of advice: don't try to boil the ocean. You begin learning some of these technologies. You're like, oh, I want to automate everything. Why stop? But obviously, you could, very difficult if you decide I'm not going to deploy anything until I have automated all processes. And that approach probably will not work without an immense amount of effort, and there could be downsides. So tackle like very small items. Again, look at that toil and look at what is your team spending time on that would be very easy to automate. Work on that, do the steps to get that into version control and whatnot. And then, grow from there, grow that experience, and take that forward. I'm going to ask if there's any questions so far.
There is nothing posted right now, Steve, but that's a good reminder for everybody. If you do have questions, I am monitoring the Q&A, so please post them there and we will address them.
Oh, perfect. Thank you, Corey.
Welcome.
All right, so kind of the first step to this process is getting processes within some sort of scriptable framework, scripting. Obviously, areas of toils thing, again, we talk manual processes that are repetitive, anything that's easily automatable. There are certain processes that might be more difficult, that you want more human intervention, although a lot of times processes that you think need human intervention don't necessarily need it as much as one would anticipate, because you're ultimately making decisions that can be very easily scripted. So again, from a traditional operations standpoint, so I'm thinking a big company, you generally have either Linux, I should say, any type of Unix-based service, so Linux, HPUX, Solaris. Generally, Shell is the language of choice. It's dirty, but it works. I shouldn't say dirty, but it compared to a more traditional, like actual programming language, it leaves a lot to be desired, but it at least is code. My personal preference is Shell and then Python. Usually what I generally do is if I'm using Shell and I feel the need to do a data structure of any type, I feel like that's where Shell begins falling flat on its face, right? It doesn't really do arrays very well or array processing. It can, don't get me wrong, I've done it. But generally, when you get to that point, you've made your shell so convoluted, you should pick another scripting language of some sort. Python tends to be a fairly popular option, so I go that route. But I would, again, lean toward what your team is more comfortable with. If you have a lot of Ruby developers, well, go with Ruby. Nothing's wrong with that. I tend to like interpretive languages just because they're very easy to edit on the fly, but nothing stops you from using a compiled language, especially like Go, which is really nice. But again, you have to really lean on your specific use cases. Because Go's compiled, it makes distribution very easy, but it makes on-the-fly editing hard, right? Which, granted, you shouldn't be editing on the fly anyway, if you're doing your development properly. But in Windows, PowerShell has become pretty popular, as of recent, at least. In Windows, you tend to get more of the administrators that expect more of a point-and-click interface. And certainly there are software packages that can't really be automated. They don't provide the PowerShell commandlets or whatnot to allow automation, but you're seeing more and more support for PowerShell within the Windows environment. So even even better Windows groups tend to already do a bit of scripting already. So that is great to see. Just as a quick demo, I am going to do some log. So I'm going to pick a quick problem, log cleanup, right? This tends to be a problem for a lot of processes. So what I have here is my quickie shell script to, well, first generate some logs. And I'm going to go here. And if you can't tell, all of this is actually in a Git repo. So you can go and look at this after the presentation, submit PRs if you don't like my presentation and you think I should change it. I will be completely open to that. And actually the one in my Git repo is a bit more commented, which granted, a lot of these comments probably don't, hopefully, make sure it creates a directory, but what I did is I essentially touched, in this example, 14 days worth of files, right? So kind of a traditional, you have a process, it rotates logs on a daily basis, but it doesn't clean them up, which not uncommon. So then here's my cleanup script. I actually was super paranoid about putting any type of file removal anywhere as an actual example. So this script actually just lists the files that it would remove because I was a bit paranoid. So again, in the repo is the more heavily commented version of this shell script. And then these are the files listed long for how to delete them. And of course, that should remove that ls, take this ls-l, replace it with an rm, that would delete it. So very basic shell scripting. But I think this is where that boil the ocean discussion happens, right? Like, don't try to pick, some gigantic problem. Start with your easy stuff that you tend to spend time on. And something like this, maybe it took an administrator, 10 minutes once a month. So not a huge amount of time savings, but it gets you started. So that's kind of where I would start is, step one, getting some scripts around processes that, are not value added opportunities for the company, right? Something that you can save some time on. And you might already have a lot of these scripts in place. Administrators already might be, I was tired of spending time on rotating these logs. I created this, I put it in a cron job. So in some ways, this step one might be just actually inventorying what shell script, what scripting that you already have in your environment, just becoming aware of where those shell scripts exist. I see a question.
There is a question. Are you at a good spot to stop, Steve?
I am actually before my step two. Oh,
Perfect.
I see.
The question is, how do you personally convince management that there will be a return on investment for automation?
That is a good question. Obviously, you got to, hopefully you're selling this to managers because ultimately they have to carve out time, from their standpoint, instead of investing in a project, you want me to actually, you want me to spend time improving my internal processes. I think that's probably the best way to sell it, is that this will provide more time in the future. And this kind of goes into technical debt, if you want to use that terminology. I think a lot of managers might understand that, like, oh, you're paying off technical debt. That this ultimately, the way I would sell it is that this frees up time in the future to allow the department to take on more projects without adding more headcount. So, if you gotta put a nice managerial surface on that, that's how I would do it. That this takes away those non-value added activities so that my department can more engage and take on projects that actually improve revenue for the company, that actually can implement projects that have a direct, effect on sales. So that's probably how I would approach it. Again, very specific for what company, for what the company's selling, what the department's doing. There's a lot of gotchas, but that's the biggest way I would sell it is, return on investment by paying off technical debt.
Yeah,
I
Steve,
feel like I should have like some sort of Gartner paper on that. I'm sure there's one that exists. So.
Steve, if you don't mind, I can comment on that as well.
Oh yeah.
I think one of the key things there is really driving home the point that we can spend a little time on this now, which means we won't have to spend repetitive time on it later, right? Invest once versus continuous investment in this type of process. So that would be my spin on it.
Exactly. Thank you, Corey. I shall continue. Thank you, Sean. So the next step, so you have these scripts, you inventoried what you already have in place, or you've developed scripts to, begin working on automating. So I think the bigger, now from an operational standpoint, the move is to get those scripts into a version of version control. Now, as a sysadmin, back in the day, my version control was copying off a script file before I made a change. So all of a sudden, I'd look in a directory and there was the script, and there was a script .back or .back.2, or I'd put a date extension on the end. So that was my advanced version control before I, really got more involved in this. But again, this goes to that, that selling point. Why put these scripts in version control? Infinite backups, which is excellent, right? I can go back to the version of a script 5 years ago, which sounds a little weird until I'm sure all of us have been in positions where if you've done a lot of heavy scripting, you made a change, a month goes by and you're like, oh, I really shouldn't have deleted that subroutine. I thought it was worthless, but it really was pretty valuable. I really wish I could go back and see what that was. So version control kind of gives you that ability. Gives you the blame reports, as we talked about. If someone makes a change to a script and all of a sudden it breaks, or you just want to know why that change was made, that's a good way to figure out a person to talk to. And again, peer reviews just to make your own scripting practices better by encouraging your coworkers to actually review. This might be a little bit challenging for, an operations department that's not used to this type of peer review. It's tough to ask for advice, but it's hopefully a good and humbling, not only humbling experience, but it helps everyone develop better routines, right? That develop skills, because my coworkers, they find bugs and I find bugs in others' code. And just reading others' code helps, improve my own skill set. I might see a technique that I wasn't quite used to, a particular procedure or statements that I was unfamiliar with. So it can help the group overall increase their knowledge. So I would encourage to get started in GitHub. Now, again, as I mentioned before, really use the tooling that you have within your company. So you might be more of an Azure DevOps shop. You might use Atlassian's Bitbucket if you're a big Atlassian company. A lot of them are floating around Git as a new version control, but if it's Subversion, I have a lot of comments on Subversion, but it'll work, right? I'm not going to say it won't. But if you're starting fresh, right, and you have no other constraints, GitHub's probably a good place to go. A lot of open source software is up there, so it's good to get familiar with it already. So I'm going to do a quick demo of. So I'm going to be daring. I'm actually going to sign up for a GitHub account live. Let me log out of my own instance before I and I have lots of screenshots. So if this fails, you can tell anyone who's done demos knows you better have backups because things go wrong. I got to create an account. So fortunately, GitHub, it's pretty easy to create an account. I just need an email address. Yeah, of course you're like that. How's that? The one you're seeing that I'm copying and pasting is one from when I demoed this a few days ago to make sure this actually all would work. So username, email, password, no preferences. Hopefully everybody realizes you can do this plus sign with Google addresses. So it gives you kind of a, it all goes to the same user account, but it fakes out a lot of places that need a separate email account, but I don't want to create one. So I prove I am not a machine by identifying the swirly galaxies and training some AI somewhere to, what kind of work do I do? Oh, this is how many, boy, this is tough for this presentation. I'm in operations. Should I call myself I'll call myself a software engineer. I write code, technically. It's just complete setup. And I'm going to go over to my email account, verify the email address. I'm doing this off screen because I just to make sure. Or maybe I'll be daring and I'll actually go to my own email. My email is verified. Ta-da! I have a GitHub account now. So I'm going to create a repository. So once you sign up for GitHub or your other version control system of choice, easy enough to create a repository. So a place to stick your software. And I'm just going to call this op scripts. Now, this is an important part if you're using GitHub and actually any other public repo, is if you want to make the repo public or private. By default, it's all public, which, if you're starting an open source project, great. If you intend to share your operation scripts with the world, that's actually would be a great opportunity to kind of push your company, out, give it some public press by sharing scripts that you find useful. A lot of teams, though, aren't prepared for that, right? Like you have built in with your scripts details of your infrastructure you don't want to necessarily release to the public. So for the most part, you probably want to keep this private. Again, if you're hosting this on a self-hosted, like a Bitbucket that's on-prem or a Bitbucket that's more internal, this might not be a problem, but just be aware that if it's public that you intend it to be public. And again, even if it's private, I would also highly encourage you not to embed passwords or other secrets within your Git repo. That's, developers are used to this as well. And you can run afoul of this, you stick an AWS S3 key accidentally within your code base. There are bots that are out there that search for, say Amazon keys. And if they find one, they try to log in and see if it has enough admin privileges, they begin spinning up EC2 instances, do Bitcoin mining and other such nastiness, or looking at S3 buckets to get unauthorized credentials. So it's not hard. I think Capital One, the big breach about a year or two ago, was actually caused. That one was a little bit interesting, but it was caused by credential leakage. That one was a little bit different. But in any case, make sure you have it as private and don't upload credentials, even if it is private. Don't depend on this to be your only protection against such things. I'm going to add a README file, but a lot of this, as you get used to more version control, you can make better decisions on whether you want to pre-populate a Git repo, if you want to use git ignore, but I'm not going to cover a lot of these things today. So we'll create a repo. So there's our script. Ta-da. And then to add a file, there's a lot of ways to do it. As you grow your skill set, I would encourage you to get used to like an IDE, an editor of some sort that has Git integration. Visual Studio Code from Microsoft is probably one of the more popular, I'll call lightweight IDEs. Heavily encourage you to explore that for your team. But for now, you could use the web interface, which is what I'm going to do now to create a, I'm going to upload a file. So add, upload file. And then I'm going to choose my file. I feel bad that I'm actually on a Windows machine using Windows Subsystem for Linux because I'm more of a Linux admin. But I actually have multiple monitors on my Windows box, and I don't on my Linux boxes at the moment. So I figure I'd be forgiven for using Windows on this. Ultimately, I just Miller that. So these are the two shell scripts that I actually had run within my VS Code or my WSL environment. So this is my home directory. This is where I drove out here for my Windows share. Official upload. So now I'm committing the code to the version control repository. So this doesn't sound, this is a very, very basic version control right for a lot of developers. But getting used to this type of editing is important for operations team as well. And just to prove like what the history would look like. So what I'm going to do is I'm going to add a quick comment. Oh, I forgot to actually add the purpose of the script and the name, which is, let's say, our company policy, right? Quick header up there. Cool. Add missing header. So I made the quick edit in the GUI. And again, this probably isn't the best way to do it, but it works. So there's my new updated script. And then here's the magic, the blame report. So if I click this, it actually will show you every line. And this file's only existed for a minute, so this is fairly unexciting. But I can see who edited it. To give you a better idea of what a blame report looks like, this is a shell script within the Kubernetes source code. So this script actually doesn't do a ton other than, trigger some other build processes. But if I click on the blame for this guy, you'll see every line, who edited it, and when. And if you hover over this, you can actually say when that build was committed. So you can tie this back to an actual pull request. So you can get more information on who made the change to this code. So again, very elemental things from a development standpoint. For an operations team, though, these type of technologies might be fairly new and certainly could be used to help make their scripting practice better, right? Getting used to committing code to version control, getting used to getting peer reviews on changes that are made. Any questions so far?
Nothing out there right now. Again, encourage anybody, if you have questions, please post them.
Excellent. So I think so one thing I want to emphasize, I don't want to necessarily cover it today because it's a bigger topic, but the concept of pull requests. So this is when you make a change. I'll do a real quick one. I'm actually going to edit this and make it remove files. So what I'm going to do, actually delete files. So in this part, I'm a peer reviewer. I look at the script like, oh, there's something wrong. I'm going to fix it. So I'm going to make the edit. And then I'm going to create a new branch, it's called. So in main is like the script, kind of the, what should, the actual script as it exists in production. And again, there's different branching strategies. I don't want to, that could get as a complex subject. I'm keeping this as a simple Git flowish type or GitHub flowish type process. But so I'm going to create a new branch that's going to patch, and you can name it whatever in this case. So I'm going to propose changes. So actually this, so not only does it create a branch, that particular process is opening a pull request. Should actually delete files. In our script. So this would be, I'm proposing a change to the group, right? I have this cool script. I'm going to add it to the repo. I'm going to edit from the repo. Now I'm going to submit a pull request. And what's nice is now I'm proposing a change. In a smaller groups, what I would generally do, either someone's monitoring the queue for incoming changes, so maybe there's some sort of integration comes up on Slack or Teams or whatever your IM communication solution is. But you see, oh, there's a new change, or you reach out to the team directly, like, hey, everyone, look at my change. Someone peer review it, please. Whatever your process is for actually obtaining comments on this. So what's nice about this is so you go into the peer review as a new user, say actually delete files. Okay, so here's the comment. Oh, we should actually delete files. So I go to files change and it tells me exactly what has changed between the old and new version. So it's very nice. I don't have to look at the whole script. I can see what are the changes Steve has proposed. Now, if it's a brand new script, it'll all be new files. But what's nice is I can say, so I can leave comments here. I don't think we should be forcing approval. So I'll start a review. So what's nice is you can have this kind of collaborative experience, right? I've submitted a single employee submitted a change. A coworker comes, reviews it, says, I don't really think that's the way we should do it. I think we should do something else differently. So then we can have a discussion. Okay, that's a good idea. And then, now this is the tough part because I use VS Code for this, so I'm not used to editing branches, but I think I can pull this off. So I'm going to edit the branch. I'm going to remove those flags. So what I did is I switched to the branch of my code that I uploaded, the new code. I'm going to commit it back to the same branch. I don't want to create a new branch. So then if I go back to my pull request, there we go. It reflects the change of the last branch. So cool. Now, what will generally happen, you can control this to require peer reviews for pull requests. Like this particular repo, because it's brand new, it's not required. But again, there's a lot of options once you begin getting into your version control system of choice, and that's very implementation specific. But in most cases, you'll require a approval. Now notice it's grayed out because I can't approve my own changes by default. Makes sense. Normally I would add a new user. I don't want to necessarily make this any longer. So what I'm going to do is I'm going to force the merge. So I'm going to merge pull request. By default, pull requests don't require any type of approval. So I'm going to merge that in. So what that'll do is that takes the code that was in that proposed state, merges it into the main repo, and now it is available. And I'm going to delete the branch because branches can get messy if they're not cleaned up, which again, this is policy type decisions. And if I look at the code, so if I go back to the code, notice my branch is gone. I'm just back to the main branch. And if I go to file cleanup, the change has been made. If I do a blame report, I can see this was the change that was committed 2 minutes ago. That's who changed. You know, if I was curious, where did the LS go? It used to be LS, now it's removing files. Well, there's your blame report. So very good. I see there's no questions, it looks like. Can you confirm, Corey? Or
Yes, that is correct, Steve. No questions. There is a comment that I think you could probably respond to, is that it mentions that the SolarWinds hack happened because of a password stored in GitHub. I know with your
yes.
security experience that may be something that you can speak to.
Yes. And actually, the next part of this presentation, we'll talk about some tooling that can assist with that. But yeah, I forgot that the SolarWinds, and especially attacking your code base and your pipelines, has become a more common method to break into companies. A lot of times these processes were developed ad hoc by various development groups, and they were designed to improve development or operations workflows without necessarily a thought to security. So there is tooling in place to prevent, or at least try to capture credentials that are trying to be committed into a Git repo, or credentials that are already in Git repositories. I'll at least talk about the process of implementing such tools. It's a bigger discussion, but I think the bigger, from a comment standpoint, training, of course, is big to push, but also building out pipelines and automated tests to try to capture passwords being embedded is also ideal. Now, the hard part is it's code, right? So it's hard. What is a password? I don't know. It's a variable, right? It doesn't look very special. There are tools that can tell, like, this looks like an AWS key. That probably is wrong. This looks like a credit card. That's bad. You know, so it can capture common parameters, or look at functions that get passed, like password parameters, and make sure that those aren't necessarily embedded in an obvious way. I wouldn't necessarily depend on that to be the absolute stopgap for such attacks, but that is a very good point of attacks that go after these software pipelines, go after the source code. I enjoy the term shift left sometimes, like we're trying to push more into the development realm, like operations security. But this kind of feels like a shift left from an attacker standpoint, right? That, okay, all of a sudden our security compromises are beginning to attack software pipelines. So that is a good point. So, and that perfectly goes into the next subject. Pipelines for your scripts. So once you've gotten to the point where you're committing code to a repo, right? You have all your scripts, you have a good process. You can add intelligence to your repository to capture, either capture formatting changes or enforce policies. Say the security, trying to capture credentials that are being committed to the repository before they're committed. Now, the hard part is you could make an argument that once it's hit a branch within a Git repo and the credentials are there, it sometimes becomes difficult to remove those credentials, right? Because they exist within Git's history, which kind of the point is never to get rid of history. It lasts forever. But at least to notify you so you know you better rotate those credentials. They've hit a Git repo that is potentially publicly available. To keep it light, I'm going to implement GitHub's super linter. And actually, I'm not, given our time constraints, I am going to log into a repo that this already has been implemented in. So what a pipeline is, it's essentially code that runs, well, when you tell it to, but essentially, usually when either you've committed any change to repository or when you've done a pull request. And it'll run code either to check for mistakes or enforce policy decisions. There are a lot of things you can do within build pipelines. A lot of times these were designed for for actual builds, right? So if I have compiled programs, what I would generally do is I would have a build pipeline design that when I do a PR, it might actually compile all the artifacts and put them somewhere so I can test, or it might deploy my code somewhere in a test environment, which is infrastructure and code. You could potentially do that, but just to get started, it's nice to at least do nice to do some basic linting, which is kind of a technical term. GitHub being very secure, I appreciate that. A technical term for ensuring that your code meets basic requirements. So the superlinter, it'll be in the, I was going to say the show notes, but the presentation notes. This is something GitHub has developed for their GitHub Actions, which is their flow pipeline. Again, very depending on what you're using on-prem, you probably already have some system for doing build pipelines. Your developers are probably fairly familiar. GitHub Actions is free. So if you're using GitHub, it's pretty nice. Now, these all run within virtual machines in the background. You never see that. You have only so many build minutes, right? So you can't just use this infinitely. But for something like this, this takes very little action. And there's a lot of tutorials on this. This actually was literally copy and pasted from the basic GitHub. Actually, I think their tutorial on actually doing linting. But as you can see, it's just a YAML file. It's running on an Ubuntu latest Docker container. It's checking out my code, and then the superlinter. And GitHub has their own, a lot of build pipelines have their own language. If you're using Jenkins, you know, you're building stuff in Groovy scripts and approaching it completely differently. GitLab has their own language, kind of similar, I believe. It uses YAML files and some other. So this is very implementation specific, but literally this is copy and paste. And now the nice thing is that I think I have an action here. Actually, so this is my commit to create the superlinter profile. So I'm going to try. So what I'm going to do is I'm actually going to do a quick PR and try to trigger this to fail. So I'm going to make a typo in my markdown file, up script. Here. Styling guidelines I should only use. Like this is a header one, you know, and I'm only using £1 but another style is to put the headers on either side. So, you know, very elemental mistake. More description. So I'm going to create a new branch and start a pull request. So as we did before. Now what's different is because I have that little chunk of code and I've told GitHub that it should run, you'll notice if I go to GitHub Actions, it's beginning to run this, this linting process. And normally you would embed, so this is the opportunity where you can embed logic to say, look for secrets. And it's something that I haven't had to do enough in the recent past to know what exists out there, but there are definitely projects in the open source world to look for common patterns for credential leakage. I'm going to pull up, so that one's running, but I'm going to pull up this run that has already happened. So you notice it's failed. And if I pull up the details, it's actually running shell check. So if anybody's familiar with Unix, Linux shell check, and shell check's a quick command that will do kind of a basic sanity check of your shell scripts to make sure you're not doing anything inappropriate. And actually, these are the scripts that I have in the presentation. So I will claim that I did this on purpose, but in reality, I just messed. I didn't follow best practices. So Oh, I shouldn't use double quotes to invent globbing and word spitting. So that's more if this variable had spaces embedded in the actual contents of the variable, it would throw off this command line potentially. So it's just warning me those really should be quoted. So as you can see, it's not necessarily failing. And then this is execution of the find command. So as you can see, it's very elemental, very basic scripts, but this is a way that you could also improve your team's productivity, because this linter will go by and actually tell you where code should be updated, and actually help you improve your coding practices. Now, sometimes the linter's wrong, sometimes the advice is bad, or there's particular cases where you don't want to use it. And most linting utilities have the ability to exclude certain lines and give a reason. So again, a more complex subject, but certainly something you should consider once you've gotten to the point where you're committing code regularly, is beginning to embed some of those other development practices into your organization and your group. And I'm just going to take a quick peek. Okay, so there's my markdown's done. So it takes a little bit of time. I don't know, conspiracy theory in me says that they just want you to pay for I think if you pay for certain levels of GitHub, you get more minutes of build actions. So I probably shouldn't be like that. I'm going to look at the Git linter, and I'm going to try to find my markdown. Yes. So this is the error I introduced in my pull request right here. And I'm going to go back to the pull request, because what's nice. Oh, I didn't actually do the pull request. Usually what will happen with these GitHub actions, you can have them actually commit to a comment within your pull request. So when you get it peer reviewed, if you don't notice the error message that comes up, your peer reviewer might. I'm just going to do a quick one. Let's see if this works.
So Steve, just a quick time check. We're starting to get close to there.
Oh,
So
yes.
Just giving you a heads up.
Appreciate it. Thank you. And actually, as you see in the pull request, it kind of shows up in big red letters. And usually you can configure it that way. So I know, well, I probably shouldn't get this peer reviewed yet. I'm not even passing the linting checks. So it's kind of a nice self-check too, as a developer, as a developer with operationals background to do that. So I would definitely look at that for your build pipelines. So actually great timing. So like I said, definitely as an operations group, I think there's a lot to be learned from, or a lot of practices that you can take from the development groups, and practices that you could use to help automate and streamline your own individual processes to give yourself more time to work on actual projects that are fun and not that toil. And hopefully from a selling standpoint, like Sean had mentioned, selling it as a return on investment. So you could also make the case that it'll improve uptime by improving your processes themselves, because the less manual processes you're engaged, the less chance for human error to get introduced. We are all human. And the documentation, if you can embed that closer within the code, that helps that process as well. Taking it further, as I said, I would definitely heavily look into an IDE like Visual Studio Code, which is free, but there's certainly a lot of other options. In some ways, a personal preference, but if you have a singular tool that the team is as standardized, even in a de facto manner, that helps for knowledge sharing. Infrastructure as code we've not looked at, but there are certainly a lot of systems that that allow you to express your infrastructure within either a language or as a higher level construct. Terraform probably being the biggest one in this area. More cloud-based, but you can certainly do on-premise infrastructure that way. Configuration management tends to be for servers that are around for a while, so not necessarily kind of the cloud-based servers, but tools like Ansible, Salt, Puppet, Chef. A lot of these are tools, and they're especially useful for more existing older servers that you can't necessarily get to the cloud, that are going to live a long time and they need to be care and fed, such as pets, the pets versus cattle mentality. But for your cattle, so for your cloud VMs that are more disposable, GitOps and Kubernetes, which again is a lot bigger discussion, but a bit exciting as well. So I definitely encourage you to look at those type of as you develop your practice, keeping those in mind certainly could be useful. So I want to thank everyone. This presentation should be available at present.r15cookie.com, which is my personal domain. It is down at the moment because of an infrastructure issue, which feels horrible that I realized that about 15 minutes before the presentation. I will find a Kubernetes cluster to host it on, which is where it's really hosted. I have my main website, which is out there as well. My contact information is out there if you do want to get a hold of me. And then I have a lot of other additional resources within the presentation.
All right. One last question here, Steve. Your current configure management system of choice?
Ansible.
There you go. Ansible.
I'll go on a little bit. I like Ansible because it's fairly lightweight and easy to implement. All you need is SSH or WinRM credentials from a machine and you can get started. So I think that lightweight process helps you get it in place right away. Everybody else, Salt, Chef, and Puppet, all require more infrastructure. Now you can make a decision that maybe that type of build out is worth it for your environment. Ansible certainly has downsides because it individually connects to machines like over SSH or WinRM. So if you have 1,000 servers, it's going to be slow. Now you can architect around that, but if you have 1,000 servers, obviously you're looking to push configuration management to 1,000 servers. Probably a bigger project that you're looking for, when you're looking at tooling. But Ansible would be my knee-jerk reaction.
All right. Well, thank you, Steve. That was great. Again, I appreciate your time this evening, spending it with us. I'd also like to thank our sponsor again, Grand Valley. We greatly appreciate your support. I would encourage everybody to check out all of our sponsors, including Grand Valley. And if you and your organization, your organization are interested in becoming a sponsor, you can find information on the GLSec website. You can also find information on the website related to all these GLSec at Home talks. Just click on the GLSec at Home tab that you'll see on the website. So thank you, everybody, for spending your time with us this evening. That's going to wrap up our time. And so everybody enjoy the rest of your night. Thank you again.
Thank you, everyone.